Hello everyone. Before we begin, let me introduce myself. I am Dr. Kamal Rawal and I obtained my PhD from School of Complex Systems at Jawaharlal Nehru University, New Delhi. I have been working in the area of machine learning and support vector machines for the past 13 years. Further, I have published research paper in reputed high-impact international journals. Also, I have been invited to deliver talks at various international conferences across the world. Today I will talk about support vector machines, also known as SVMs, their algorithm, their application and methods to implement them. I would also discuss live case studies drawn from my own research as well as from the published research papers. The whole training process is divided into following topics. First of all, we'll talk about what exactly support vector machines are. We study about its history, we discuss its applications, and importantly, you understand concepts such as vectors, machines, and feature space. We also study advanced concepts such as linear classifier, classification margins, support vectors, soft margins, kernels, kernel tricks. In the last part of the module, I will take up case studies on identifying disease genes, role of SVMs in cancers, handwriting recognition and image recognition. Alright, let me first talk about history of SVMs. Support vector machine is a supervised learning algorithm developed by Vladimir Vapnik and it was first heard in 1992. It was introduced by a group of scientists named as Vapnik, Bozer and Goyan in a conference known as COLT 92. It is said that Vladimir Vapnik has mentioned this idea in 1979 in one of his papers, but its major development occurred in 1990s. For many years, neural network was the ultimate champion because it was the most effective learning algorithm during that time. SVM became famous when using images as input, it gave accuracy comparable to neural networks with hand-designed features in a handwriting recognition task. Currently, SVM is a widely used system in object detection and recognition, content-based image retrieval, text recognition, biometrics, speech recognition, cancer diagnosis, and understanding of genomic data. Let us look at the working definition of SVMs. SVMs are a supervised classification method based upon conversion of input objects into vectors, subsequently projecting them into higher dimensional space using feature projections, obtaining an optimal hyperplane that separates data into different classes, and finally classifying new data. This method simultaneously maximizes the geometric margin between two classes and minimizes classification errors in an efficient and rapid manner even for high dimension data. This definition was given by Burgess in 1998. Let me explain this by defining the key concepts. We will take up a small example on image recognition to understand the process of SVMs. Now, classifying data is a common task in machine learning. For example, we need to recognize a person using the photograph. In 2011, while hunting for one of the major terrorist leaders, security agencies used image recognition software. FBI and American soldiers attacking house of Osama bin Laden had to identify Osama amongst many potential threats. Though soldiers had cameras on their rifles and helmets, but that is only half the equation. They do not recognize anything unless they are supported by image recognition or machine learning system. As a soldier's camera pans over faces, the system converts them into digital images and compares them with the stored photos. First, the system searches for the oval shapes and detects that a face exists in a video stream and saves it as a digital image made up of tiny dots or pixels. The system then creates a simplified map of the enclosed face based upon the light value of each pixel. Lastly, it compares the newly created pixel map with the existing photos and selects a similar match if one exists And that is how they found out Osama bin Laden amongst various potential threats present in the house.